What happens when a massive wall of ice fractures and collapses into the ocean with the sound of thunder? This process is known as iceberg calving. It is not melting, it is the mechanical breaking of glaciers that releases large blocks of ice into the sea. This narration examines iceberg calving as one of the most powerful natural processes on Earth. Icebergs do not form because ice slowly dissolves into water. They form because glaciers fracture under stress and release large sections of ice all at once. Calving is a central mechanism by which glaciers lose mass and reshape polar coastlines. This script explains how calving occurs, why it happens suddenly, and how it affects oceans and climate. If you like this kind of videos, subscribe to my channel. This will motivate me to make more videos for you. Let's move to the topic without wasting more time. Iceberg calving is the process by which large pieces of ice break off from the front of a glacier or ice shelf and fall into the ocean. These fragments become icebergs and drift with currents and wind. Unlike melting, calving occurs abruptly. Cracks can develop over long periods, but the final break typically happens within seconds, releasing large amounts of stored stress. Glaciers form on land from compacted snowfall and move slowly downhill under their own weight. Over long timescales, some glaciers reach the ocean and extend outward, forming floating ice shelves. These shelves remain attached to the glacier behind them while being supported by seawater below. As ice continues flowing forward, pressure builds at the front. Calving relieves that pressure by releasing sections of ice into the sea. Icebergs break off due to a combination of gravity, structural weakness, and environmental forces, rather than surface melting alone. As glaciers stretch and bend near their seaward edges, fractures develop. Warmer ocean water melts the underside of floating ice, weakening it from below. Waves, tides, and storms add additional stress. When the ice can no longer support its own weight, it fractures and collapses into the ocean. When calving occurs, it is sudden and loud. The falling ice displaces large volumes of water, generating powerful waves that can be dangerous even at a distance. The impact often sounds like thunder or an explosion. Newly calved icebergs may rotate or flip, exposing dense blue ice that was previously submerged. This marks the formation of a new iceberg that may drift for thousands of kilometers before melting. Icebergs float because ice is less dense than seawater. Although they appear massive above the surface, roughly 90% of their volume remains underwater. This submerged mass is what makes icebergs particularly hazardous to ships, since most of their structure is invisible from above the surface. After calving, icebergs move with ocean currents and wind. Some remain stable for long periods, while others rotate, fracture, or erode unevenly. Their shapes change as melting occurs above and below the waterline. Over time, icebergs can develop arches, cavities, and sharp ridges shaped by temperature, waves, and mechanical stress. Iceberg calving plays a role in ocean ecosystems. As icebergs melt, they release fresh water and trapped minerals into surrounding seawater. These nutrients support plankton growth, which forms the base of marine web foods. However, large-scale increases in calving can also affect ocean salinity and circulation patterns, with broader consequences for climate systems. Climate change is increasing the rate of iceberg calving in many regions. Rising air and ocean temperatures weaken glaciers and ice shelves, making fractures more likely. When land-based ice enters the ocean through calving, it contributes to sea level rise. While calving is a natural process, its acceleration reflects changes in global temperature patterns. One major example occurred in July 2017, when a section of Antarctica's Larsen C ice shelf fractured and released an iceberg known as A68. The iceberg covered approximately 5,800 square kilometers, making it one of the largest ever recorded. Its formation followed years of crack growth and thinning along the ice shelf. Another example took place in Greenland in August 2010, when the Petermann Glacier calved a massive iceberg measuring about 260 square kilometers. This event removed nearly a quarter of the glacier's floating ice tone and was linked to warming ocean water undermining the ice from below.
Scientists monitor glaciers using satellites, aerial surveys, and ground-based sensors to track fracture growth, ice motion, and thinning. While the precise timing of individual calving events remains difficult to predict, high-risk regions can be identified. This monitoring helps protect shipping routes, research stations, and coastal infrastructure. Iceberg calving represents the mechanical release of stress accumulated in ice over long periods. It is driven by gravity, structural weakness, and environmental forces rather than surface melting alone. Understanding this process clarifies how glaciers interact with oceans and how polar ice contributes to global sea level change. Thanks for watching. Like this video and subscribe to my channel for more related videos.